Hey, Prodigy Sim here. I wanted to make a quick little video showing how I find some Windows offsets given Linux offsets. Uh, this is a pretty, I don't know, this is kind of an interesting example. What we have here is we have a plugin written by Visor that tries to stop SI from staggering each other. One of the things that this plugin does is it checks against what these Linux SI domination offsets. These get used at, I don't know why they're being used, if I'm being completely honest, but they have some entity that's a survivor. They get the raw address of this entity, so this is going to be like a C-base entity. It turns out to be CTerrorPlayer for most survivors and infected in memory. And it's just reading that entity address plus these offsets. So it's reading like a variable in the CTerrorPlayer class, and we have just hard-coded offsets of like how many bytes into CTerrorPlayer is this variable we're looking for. So these variables are basically like I think they probably call them like H smoker attacker, H hunter attacker, or something like that. It's just like for each survivor, keeping reference to which SI is currently dominating them, specifically like which player, not just is a smoker on me, but which player, I believe. And so yeah, it's just looking up directly on there. So I decided I want to try to, one, confirm these offsets, and two, see if they're being used on, see if I can find the Windows offsets for them. So in IDA, I have loaded up, I have the old version of the game, which is 2155. This plugin was known to be working on 2155. And I also have the new version available. I'm mostly going to work in the new one, but I'll just call out the old one. But let's start with the old one and just use it to make sure like we can find a reference to these variables. We need to find, if we can find where these old numbers were used in the old binary, then we can have more confidence looking in the new binary. If we find different offsets, we'll see that they're kind of used in the same way, things like that. So what I was going to do to try to find those, I've already done this. This is kind of backtracking, but basically, I'm just going to look for some function on CTerrorPlayer. So I go over here in the functions window, and if you just start typing here, you can start searching for methods. So I'm going to look for CTerrorPlayer, and then once I'm on CTerrorPlayer, I like to sort the function window, see a bunch of stuff. And I was going to look for CTerrorPlayer is, because there's a lot of functions that like check some state about the player, and they're just compiled as a function instead of directly checking the variable. And just going through this list pretty quickly, you can find, I'm looking for anything about dominators, and I find is dominated by special infected. Let's go ahead and check that out. The game calls any capping SI dominators. So we find a function. If you have pro version of IDA, or maybe you're using Ghidra or something, you can get a decompiled view, which is much easier to look at. I'll show you what that looks like, but yeah, I'll show you what that looks like because that's what I use to find this stuff. It's just going to make it into something that looks more like C or C++, and that's a little bit easier to read for me. So right here, this function is not super long, and it's mostly doing a ton of checks right here, checking something in the entity list. And we actually see it's reading from A1, which is this pointer. It's always going to be the first argument on any of these like class-based functions, is going to be a CTerrorPlayer instance, which is the entity of the player. On it, we actually see these offsets. We see these reads from pretty big numbers, and if we go back to our sistaggers.sp, we see like smokers 12384. There's also 16008, so 12384. We go in and take a look at this, and we see 12384 right here, 16008. Then the next two are 15976 and 16128. 15976, 16128. Cool. So I would presume that both of those are, I mean, it's a pretty safe guess. These are pretty like high numbers. Well, the number's high and it doesn't look like any sort of common number. It's not an even number. It's not a round number. It's probably safe to assume that that's what these are talking about. So we confirmed it in the old binary, and then in the new binary, the new version of the game, it's pretty simple to just do the same thing. We just go to CTerrorPlayer is dominated by special infected, and open it up in the decompiled view, and we see actually the exact same numbers, 12384, 16008. I've been looking at these numbers all day, so they look familiar. If you have to do it in the IDA view because you're using the free version or anything like that, it is possible to find these. It's going to be in instructions that look like they have the brackets around them. That's a pointer dereference, and some values in a register, some pointers in a register, and we're adding some offset to it. So these numbers are pretty big. So this has a lot of hex digits. Like this is really short. That's +8, right? This one's pretty long. arg0 is for something on the stack. So I think it's these long numbers. And one thing you can do is you can right click on it and you can hit H and you can switch it to decimal, and we'll see that's 16008, 13284, etc., etc. So there's another one right here, 161828, and then is this one of them? This might be something different. 10860, yeah. So where's the last one? 2, 3, right here at the start of the function. 15976. Cool. So that's all well and good. We were able to find a function named is dominated by special infected right here to find those offsets. Nice and easy, right? However, finding it on Windows, I'm using Ghidra for Windows because my IDA does not like, my version of IDA that I have does not really like the Windows binaries. So I need to find some way, what my strategy is going to be for Windows, and I haven't done this yet, so this is doing it live, is that I want to find a function that calls is dominated by infected. Because on Windows we don't get symbol names in those binaries. Every function is just named fun whatever. So if we want to find a function, we need to find like a unique string or something unique that we can search for and kind of like follow traces from there. So unfortunately, this function of ours, this is dominated by special infected. It's not referring to any strings. I mean, these offsets are pretty unique, but these offsets are almost never going to be exactly the same on Windows and Linux, especially for like a variable offset in a giant class. It's very likely that somewhere in there's some extra bytes. So my strategy here is I'm going to try to find a function that calls is dominated by special infected that has a string or has something else more unique about it that I'm going to be able to find in the other binary for just searching for strings. So I'm going to hit X in IDA. You can do this on either view. You can hit X on the function name to find references. I believe that's also, yeah, jump to xref to operand. And so these are all the places that function is referenced. So I started looking through these. I did not find anything yet. So I'm kind of some method to the madness is like, think about if you can find a function that's less complicated, then it's going to be easier to compare between Linux and Windows. What we're going to try to do is like, yeah, just be able to kind of match up the Windows version and the Linux version and see how things go. So like you can just kind of take wild guesses, but like this one, the offset is 101B, which is a huge number, whereas this one, the offset is plus F2 into the function, which suggests probably a shorter function. This one's plus 57. That's pretty low. Maybe I'll start there. See car prop alarm touch. And I'm gonna try not going into the IDA view. It's actually a pretty long function, but I think these are some strings right here. Panic event, car alarm. I'm just gonna go ahead and do F5, but you can do these same steps down there. So wow, we actually have, so is dominated by special infected is called almost at the beginning of the whole function, which is pretty cool. That means we should be able to find it pretty easily on Windows. But now we've got a ton of strings. Triggered car alarm. That's called in a few places. So again, I need to find something that's more or less unique. Otherwise, I'm going to have to keep searching ad nauseum to find like references to references and sort of weave my way through. So I'm going to try to find, is context alarm more unique? No, it's called in a ton of places. Subject is called in a ton of places. Panic type, probably called other places. Panic event. Dang. I was really hoping it would be that easy. Triggered car alarm. I no longer like this function. One thing I could use other than strings. So yeah, none of these strings are unique to this function. So I could search for triggered car alarm in the Windows binary, but then I would have to search through all 4 of these functions and figure out which one I'm looking at. It might not be the hardest thing in the world. But one other thing we could look for, I'm probably not going to resort to this, but this function also uses, I think I saw in the disassembly, like up here. I thought this thing used some static floating point values, and floating point values get stored in the data section sometimes. So this is 0.0, but I thought I saw somewhere else something said. This right here. So this v6 equals dword BA595C. Let's see if that's unique. That is not unique. But they end up looking like this. If we go back to the IDE output, you'll see like, I don't know where exactly, but you can find this is probably some floating point constant. All right, so that is not unique. Okay, I think I kind of like triggered car alarm though. Hopes being we can find a function that looks just like this. Let's take a look at input survivor standing on car. See, this is checking, setting some criteria on the AI for panic event, context alarm, just look for other strings like that. This thing does the exact same thing. That's not good. Oh, that is the function I'm looking at. Oh no, this is a completely different function that looks almost exactly the same. It doesn't have that call at the top. All right, so we have to X out of that and go back into this. Yeah, forget about this function. So let me get back to is dominated by SI. I'm going to open it in the F5 decompiled view just because it instantly puts me into the new pseudocode version. Let's try out drop carried prop. This has a gas can force prop string. Dominated special infected is not too far into the function. Might be pretty easy to find. Let's see. This string is only used in 2 places, and they're both in the same function. So is it also used down below? Maybe it's just the assembly is referring to it twice, but actually it's only there once, something like that. Yeah, it probably just gets shuffled around. Like if we go to the IDA view of this function, which we don't have here, hold on. We should see gas can force drop. It's just like in 2 different paths, but there's like probably an if else or something. Cool. So I'm going to go ahead into Ghidra, and Ghidra searching for strings is a little different. In IDA, if you want to search for strings, you can go to Open Subviews, View Open Subviews, Strings, or it's Shift F12, and it looks something like this, and you just start typing in your string like gas underscan force drop, and it shows up there. In Ghidra, it looks, it asks you to set up your search parameters. I just default that. And then it pops up a new window like this. We're gonna look for gas can shit. You know what I just realized? This is not the correct binary. This is the engine binary. Do I have a new? I have a relatively new server binary. Let's just use this. This is fine. Sure. Server binary, sweet. So here we're gonna go search for strings, and we're gonna look for gas. It's gonna take a while to index all the strings. Great, gas underscore, we find a bunch of stuff. There's gas can force drop, which I believe is the one we're looking for. And here I'm gonna, you could do, and if you're in IDA, you could still do X, but here I go references, show references to this symbol. And we find it in one function, which is good. And this is our function on the right, the decompiled view. So now we have to compare this to IDA. So I'm gonna go like left sidey, right sidey, which is the technical term, I believe. So here we have our two functions. Man, I'm gonna have to like move this all the way over. So there's gas can force drop. Here's gas can force drop. Man, this function is big. Okay, so we need to find this guy on this side, right? So we could go bit by bit. There's an if else here that this sets result to 0. So we may also just be checking the inverse of this. So if it equals 0, do something. If this, so this the function call should be one of these fun calls. So we could just click through onto each of them and see if we find the one we're looking for. I think I may have just accidentally found it. I'm gonna hit back. So what does it do with this call? It checks, it makes this call, and then I don't know what it's doing with the result of it because my analysis is messed up. But it happens right after a reference to GP entity list, which is probably this guy right here. This one pointer to the data section here is pointing to it's, I don't know why Gidger doesn't highlight stuff the same way, but this variable is being referred to here and here and here and here, and it does this same thing where it like ands it with OXFF. We see the same thing in here where it refers to the entity list and then ands with FF. So this function call is after an if check on something with the entity list. And then here it's checking the result with 0. Okay, so this is checking the result with 0 here as well. And then param1, which is A1, plus 157C. Can I swap this over to, I can swap this one over to hex over here. 1584, these look kind of similar, checking something, blah, 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 blah. I'm gonna guess it's this function. Yeah, or get special infected dominating me. Oh, both of those sound good. Whatever, I'm sure they're both reasonably good functions. I'm gonna click through, and we see on the left, and we see on the right, there's a bunch of these, yeah, this looks like the same thing to me. So again, we've got some global variable. We're doing this and FFF thing and FFF thing. And we're checking some offset, some big number, which is that big number and that big number and that big number. And do we get one more big number? Thinking face. Is this not the right? Oh, there's another. This is like something inlined here. I think this function call is not over here, and this might be our last one. Yep. So there's our last one, 3F14. Can I swap these over? I'm just gonna swap these guys over. Well, decimal. So what happened here is on these were probably in the source code a bunch of different functions, like is, you know, get smoker attacker, get charger attacker, get jockey attacker, and the Linux binary just decided to inline them all, and the Windows binary did not. So one of them got pulled out to a separate function call for some reason. But anyway, so these are our numbers. They should keep the same ordering in the class. The variables should keep the same ordering in the class. Just the exact number of bytes is going to be different. So we can take a look. Can I swap this over? No. We'll just take them as hex. I mean, so we've got 33F8, which is pretty low. 3E9C is the highest, 3E7C, and then this one's 3F14. That's our highest one, which should be this guy. So yeah, let's take the lowest one, which is this 13284, and now it's 33F8. We can just use the standard Windows calculator to convert these. So we've got 33F8 is 13,304. Put this into our game data. Sorry, I made a game data for this. So 13304. And then the next one, where's Gidra? There we go. The next biggest one is the charger. That should be this guy, 3E7C. Uh, 15996. Interesting. It's like 20 bytes different. That's what we're seeing. 20 bytes different, 20 bytes different. So next one should be the Hunty, and he is +2 in hex up from there, so that should be 32 bytes greater. So we could just add 32, but I'm lazy. I think it'll end up in 40. We're gonna go 3E9. Nope. Have to type in hex mode. 3E9C. 16028. Hey, it's 20 bytes increased from the Windows one. Yeah. And jockey is our last one, who's hiding in this function. 3F14. 16148. All right. So I've decided that I've found these offsets in the Windows version. It's kind of nice that they're only 20 bytes apart. Makes it pretty easy to see that we correlationally got these at probably some good values. I'm gonna have to actually test this on Windows if I want to believe these. I'm probably not going to test them because I don't even know what this plugin does and how to test it, but I might. I don't know. But I just wanted to go over like what the process is for checking, looking stuff up on Windows using the server binary as a reference for just some random data, some random numbers that we needed to find. Cool. So as a recap, first we found the existing numbers in the Linux binary by just searching for a function that has a name. We could also, another thing you could do, I should have mentioned this at the start, but another thing you can do is if it's a big, pretty unique number like this, you can do Alt-I, which is the find immediate value search. And you put in that number and it'll find every place that number is used in the whole, as like an operand to something. It'll find every place it's used in the whole binary. It can take a little while, but we should find it. We didn't find it. Oh, it actually, it showed me all of them. That's not what I wanted. I wanted to like go to next one. Yeah. So when I search through, I see set accuracy. It show, you can see the function name that you end up in down here. Show accuracy for this shot. That has nothing to do with Dominator, so I'm going to search next. Check stuck, no. Elevator push player, no. Avoid actors operator. Check target scan is potential target, could be relevant. So yeah, this isn't quite as good. Should collide, get tongue destination. I mean, this is possible that it's helpful. But yeah, we just kind of went in, found some function that maybe would be using this data. We're going to write that down for later. Then we check the new version of the Linux binary to see if the offsets had changed in that function. They had not. Then we found references to this function that could be identified based on strings across both binaries, which we used cgascan drop carried prop. We found that string, gascan force prop. We looked it up in our Windows binary. We did a search for strings. We found it in our Windows binary. And then we compared the Windows and Linux versions of this did carried prop function to find that same call happening on both binaries. We went into it and then found those offsets we were looking for, those param1 plus whatever's. Cool. So that's just kind of a quick walkthrough on what I was doing there, in case it's helpful for somebody sometime in the future. Peace.